Good, sir.
Very good. Okay, still some people to join. Okay. So did you practice the basic radar plot question, beta?
Yes, sir.
Okay, beta. Great. Very good. So today we will be moving on to our next topic in radar plotting. Now these are very, very important topics. The first one is how to predict action to take. So we will be given a situation, a scenario, targets would be there. We have to report those targets, plot them, make the basic plotting triangle, and then we need to ascertain whether there is a close quarter or collision kind of situation developing. And if it is developing, we need to predict what action is required to be taken to attain a minimum CPA or a particular TCPA. So this is what is required in these questions. And this is the first topic for today. So very, very important concept. And iske baad, once we cover this, then we are going to cover how to handle multiple targets. पहले इसको एक single target से देखेंगे. And once we are comfortable with the method, then we will take multiple targets. So if there are multiple targets, how to take care of all those targets at once. Okay. Like आजकल missiles बहुत सारी चल रही हैं ना. So you have missiles now which have multi-target technology. They are called as MIRV missiles. So they can target 3, 4, 5 targets simultaneously. Very difficult to neutralize. Okay.
Sir, I have a doubt, sir.
Bolo beta.
Sir, I'm getting difficulty in plotting relative bearing, sir. If relative bearing of a target is given, then how to plot, sir?
Okay, all right. Relative bearing, huh? 1 minute.
Yes, sir.
1 minute. बेटा मैंने अभी आपके व्हाट्सएप ग्रुप पे ना एक स्लाइड शेयर की है. Just go through that slide, read it, and then apply it to a relative bearing question. You should get the answer.
Okay, sir. Okay, I'll check, sir.
Okay. Okay, great.
Good evening, sir.
Good evening, beta. So beta ready हो? चलें अपने next topic पे?
Sir, I have one. The question number 7. The first target, target 1. In that question, I wanted to ask about the aspect.
Question number 7. Okay, let's see,
And
beta.
target A.
Give me a minute. Let me open up the sheet here. Okay, all right. Question number 7, na beta, target A.
Yes. So in
So
this,
this is
I got the answer. The answer matched also. But conceptually, I am not able to get the hang of it. Like you said, we have to put the vessel on A.
Yep.
And compare it to C. Where is it falling? So if we see here, it is coming on the. Oh, wait.
Okay, hold on. Let me explain. Now you see in this 7A triangle, we have the WA vector. WA vector is there, right, beta? So that gives us the course of the target vessel, right?
Right.
So let me make a rough diagram of the target ship here. ये मैंने target ship की एक rough diagram यहाँ पे बनाई बेटा. And let me extend the target's heading or target's course slightly further. So मैंने WA को extend कर दिया बेटा. So this extended line now represents the heading of the ship, right?
Yes, sir. So I had made some mistake because now I understand and it is very clear. So,
Okay, great बेटा, great. मैं complete भी कर देता हूँ. Now from this point A, if you draw a line joining up to the center of the screen, that is our ship. This basically represents the bearing of own ship from the other vessel. And this angle which you have between the heading and the bearing of own ship is your aspect. And since we are on the starboard side, this is going to be green. Okay, beta, clear?
yes, sir, clear.
Okay, great, beta, great, very good. So closing this down. Okay, great. Most of the people have already joined in. So शुरू करते हैं बेटा, आज का टॉपिक शुरू करते हैं. ये बहुत इंपॉर्टेंट चीज़ है जो आज हम करने वाले हैं रडार प्लॉटिंग में. What we did in the last class was very, very basic. Okay, you had done ample questions in radar plotting, ROC course also. So what we are going to do today, ये भी आपने किया हुआ है, basic stuff you have done in ROC course. So ये refresh भी होगा and these question can look little complicated and tricky. So ध्यान से आपने सुनना है and pay your attention. We will pick up some examples और ये हर एक type का जो question है, how to predict action to take, I will pick up an example and show you how it is practically done on the plotting sheet. फिर multiple targets में भी ऐसा ही करेंगे. We will pick up an example and see how it is to be handled. Now the questions can be lengthy. Okay, so questions can be lengthy, procedure can be lengthy and tricky. So pay attention. चले बेटा, ready हो? Okay, let's go. Having understood the basic plotting technique, we are now in a position to progress to our next plotting method, that is predict action to take by own ship. So we have to basically predict the action to take. Action could be a alteration of course and a alteration of speed by own ship to achieve a desired CPA. Now this is what is practically required on board. We need to find out that to obtain a desired result, such as a desired CPA, closest point of approach range, what course has to be, what action has to be taken. The action could be alteration of course, action could be a alteration or variation in the speed. What has to be done by the own ship so that we are able to maintain the required CPA? Or in case you have a collision or a close quarter situation, how should we avoid that close quarter situation? What should be our action? And what are all the possibilities available to the navigator? The possibilities could be, to give you an example, alteration of course to starboard. Another possibility could be alteration of course to port. And the third possibility could be increase or decrease of the speed. So we have to find out what all possibilities are there. And later on, we have to evaluate that as per the rules of the road, collision avoidance rules, which out of these possibilities is the most appropriate in compliance with ROR. Let us now see an example where we are required to take a action for achieving a particular clearance or CPA range. We have the question on the screen. On ship's course is 055 degrees true, speed 15 knots. Find the CPA, TCPA, course, speed and aspect of the below target. The bearing and range of the target is given. At 0930, bearing is 105, range is 14 miles. After 6 minutes, 0936, the bearing is given as 105 degrees, range is 11.5 miles. And at 0942, the bearing is 104.5 and the range is 8.9 miles. We have to let the target pass ahead with a CPA of 1.5 miles. Find the 3 possible actions. These could be alteration of courses or speed to take at 9:45. Which of them is most preferable? Now we need to maintain a CPA of 1.5 miles with this target. Important thing to note is that the action is taken at 0945. That is 3 minutes after the last observation. So if you see, the first part of the question is a simple plotting exercise. So on ship course and speed is given. We have to find the CPA, TCPA, course, speed of the target and aspect. So this is a simple basic plotting question. The second part requires us to predict our action. So let us see how do we do this question. Let us first have the plotting sheet. I have not shown the full plotting sheet so that we can zoom in. We have shown a specific part of the sheet so that we can zoom in and the diagram is clear. Now let us, as usual, first of all, mark the scale. The scale which we are using is 1 centimeter equal to 1 nautical mile. Let us now show the center of the plotting sheet as C, Charlie. Let us now show the on-ship course and speed. On-ship course is 055, so you can see the green color arrow marked at the circumference at 055. The speed is given as 15 knots. Speed is also marked. Let us now plot the first observation, first position 0930. The bearing is 105 and the range is 14 miles. So from point C, using the graduations on the circumference at a bearing of 105 and at a range of 14 miles as per our scale, we mark the first relative position of the target. This observation is taken at 9:30, so the time is also mentioned alongside. And as per our nomenclature, this is named as O, Oscar. So we have the first position, relative position of the target on the plot. Let us now mark the second position. You see the second position coming up. This observation is taken at 9:42. We can also plot the 9:36 position. It will be somewhere in between these two observations, but we have not shown the 9:36 position here for clarity. In actual plotting, all the 3 positions can be shown. You will observe that all these 3 positions, they fall in a straight line. So we have straight away shown the 0942 position, the final position after the end of the plotting interval. And as per our nomenclature, this is marked as A alpha. If we join Oscar to alpha and extend it, this gives us the line of approach. You can see the line of approach coming up. It is represented by double arrows. So you see the double arrows coming up on the line of approach. And you can now drop a perpendicular from Charlie to the line of approach, meeting at the line of approach at point November. November point is our CPA, the closest point of approach. Now, as we have done in our basic plot, from point O, we draw the course of the ship in reverse. You see the green color vector drawn in reverse. The free end of this vector is named as W, Whiskey. Whiskey to Oscar represents own ship course and distance covered in the plotting interval, that is 12 minutes. Now we join W to A, Whiskey to Alpha, and we are aware that this Whiskey to Alpha vector, WA vector, gives us the target's course and distance covered in the plotting interval of 12 minutes. So we can read off the target's course from here. We can measure this distance WA as per our scale, and by interpolation we can find out the speed of the target. So up to here we have done a basic simple plot and we have obtained these answers. The CPA, which is Charlie to November, this distance measured as per our scale, gives us a CPA range of 0.2 miles. We can also find the time to CPA. How can we do that? We measure alpha to November distance, alpha to November divided by Oscar alpha multiplied by the plotting interval, which is 12 minutes. So ship has covered Oscar to alpha distance relatively in 12 minutes. We have to cover alpha to November, and by interpolation we find out the time, and adding this time to 942 gives us the TCPA at 1003 hours. The course of the target WA is measured as 322 degrees true. The speed can be measured using the distance Whiskey to Alpha WA, and it comes to 20 knots. And the aspect is obtained as 37.5 degrees, and it is red. Red indicates that own ship is on the port side of the target ship. So up to here we have done a basic plot. Now proceeding ahead. Since the action is to be taken at 0945 hours, we have to first predict the position of the target ship at 0945. So basis this distance Oscar alpha covered in 12 minutes, we find out the distance which will be covered in 3 minutes, and from point A at that much of distance we mark off the predicted position of the target. Let us name that position as P, Papa. So you can see Papa point coming up on the screen, and we have mentioned the time 0945 along with it. So at 0945 the target is expected to be at point Papa. Any doubts coming up to here, beta? Very good, beta. Great. Let's move ahead.
Sir, just one question.
Go ahead.
In the bearing, sir, if there is a steady bearing, can we just plot the first and the third plot, or in the paper we will do the second plot as well?
बेटा आप चाहो तो पहले फर्स्ट और लास्ट को प्लॉट करके अपनी प्लॉटिंग कर लो, बट लास्ट में आई वुड रिकमेंड कि आप मिडल में ना जो बीच वाली बियरिंग और पोजीशन है वो भी प्लॉट कर दो. डोंट लीव इट. समटाइम द एग्जामिनर मे थिंक दैट आपने बीच वाली पोजीशन प्लॉट नहीं की है. Okay. Now we need to have a CPA of 1.5 miles. So what we do now is we open up our compass equal to this CPA range, that is 1.5 nautical miles as per our scale. We center our compass at point C, point Charlie. With center at C, point Charlie, and radius as our desired CPA of 1.5 miles, we now draw a CPA range circle. So you have the CPA range circle in our plot now. Now what we do is from point P, predicted position of the target at 0945, we draw a tangent to this CPA circle. So from point P, we draw a tangent to the CPA circle. This tangent touches the CPA circle at this particular point. Let's name this point as N1. So you can see November 1 or N1 should be our new CPA point. If the target line of approach becomes Papa November 1, PN1, then you will see the CPA would be Charlie November 1, and which is the radius of the circle, which is taken as 1.5 miles. So to have a CPA of 1.5 miles, the target should move on a relative line of approach PN1, Papa November 1. So this is the new line of approach which is desired. We have shown this using 3 arrows. Now there is one more possibility of drawing a tangent. We can draw a tangent from point P onto this circle in this particular way also. Now why have we picked up the tangent PN1 and not the other tangent? Reason for that is, in the question it is mentioned we have to let the target pass ahead of us. Our ship is steering a course of 055. So our ship steering 055, the target has to pass ahead of us. That means on this particular tangent line, Papa November 1. If we take the second tangent in this particular way and the CPA is somewhere here, with our ship moving on a course of 055, the target would be passing astern of us. So that's why we have not picked up the second possibility of the tangent. Is this part clear, beta? Any doubts?
So I have a doubt regarding drawing Papa, that predicted position. We have to draw it based on the speed of the ship. Speed of the
no, beta.
target.
It is basis the speed. You see Oscar to Alpha distance, which you have shown in your plot, was covered in 12 minutes, beta. So measure this distance.
Okay.
Measure this distance, divide by 12 and multiply it by 3. So by using simple interpolation, you will get the distance covered by the relative line of approach in 3 minutes.
Yeah. Okay, sir.
Okay. Okay. You cannot find this out by the speed of the target, because the speed of the target or speed of own ship will refer to target vectors WO or vector WA. The Oscar Alpha is basically the movement of the ship on the line of approach. It will be different from our speed or the target speed.
सर वो ahead और astern वाला सर थोड़ा सा repeat कर देंगे, मेरा voice कट गया था उस टाइम पे आपका थोड़ा.
Okay, beta, no issues. You see in the question they have told us that the target should pass ahead of us. Now our heading is 055. So you see if I draw the second option of the tangent, now that second option will be passing southwest of my ship, okay, which will be astern of me. That's why we have not shown the second tangent. What you can do is, if you have difficulty, you can assume your ship at sea, assume there is a ship at sea heading in the direction of 055. Immediately you will realize that this new line of approach which you have made, Papa November 1, is passing from our bow.
Understood, sir. Understood.
Okay, beta. Great. Now, since we need the target to follow Papa November 1 line of approach, what we do is we now draw a line from point alpha. From point alpha, we draw a line parallel to the direction of PN1 or N1P. That is our new line of approach. So parallel to new line of approach, we draw a line from point alpha. You can use whichever plotting tool you have, set square, parallel ruler or sliding ruler. So from point alpha, we draw a line parallel to our new line of approach, that is Papa November 1. You can see that line coming up. We name the free end of this line as Bravo. So we want the target to move on this line of approach. Now this line Alpha to Bravo intersects the own ship course line, that is WO, green color vector, at this particular point. This is the intersection point of the new line of approach and the own ship's course and distance vector WO. Let us name this intersection point as O1, Oscar 1. Now, if you look closely, if our vessel, own ship, covers distance WO1, if own ship covers distance WO1 in a interval of 12 minutes, then in that case, WO1A would become the new relative triangle. If our ship covers a distance of WO1 in a period of 12 minutes, then WO1A would become our new triangle, WO1A. You can follow the laser pointer. WO1A will be our new triangle. And O1 to A will become our new line of approach. And effective from 9:45, this is going to ensure that the required 1.5 miles CPA range is achieved. So this gives us our first option, that is the reduction of speed by own ship. So instead of WO, if we cover a distance of WO1 in 12 minutes, we will be able to attain or achieve a CPA of 1.5 miles. Now we measure this distance WO1 using our scale. So basis this distance WO1 in 12 minutes, we interpolate and calculate the required speed, and the required speed comes out to be 10 knots. So our ship, which is presently moving at 15 knots, if the speed is reduced to 10 knots, on ship target would be WO1, the line of approach would be O1A, and effective from 9:45, this line of approach will result in the vessel CPA coming at point November 1 and 1 and maintaining a range of CPA range of 1.5 miles. So up to here, beta, any doubts coming in?
Negative, sir. Badhiya.
Very good, beta. Very good. So we have got our first option, a reduction in speed leading to the desired CPA of 1.5 miles. ये पहला option है बेटा. अब हम और options देखेंगे. What other options are available to us? Let's see that. Let us now see if we can attain or achieve the desired CPA using an alteration of course also. Now to find out the alteration of course, we pick up our compass. We open up our compass equal to the length of vector WO. This vector represents the distance covered by the ship in a period of 12 minutes. So we open up our compass equal to WO, center our compass at point Whiskey. With center at Whiskey and radius equal to WO, we draw an arc. You can see the red color arc coming up on the plot. Now this arc cuts the line AB, which is parallel to our new line of approach. The arc cuts the line AB at 2 points. One is at this particular point. Let us name this point as O2, Oscar 2, and the other intersection point is this particular point. You can follow the laser pointer on the screen. So this is the second intersection point. Let us name this as O3. Now let us join W to O2 and W to O3. We have joined W to O2 using this vector, the green color vector, and now I am joining W to O3. So we can see WO2 and WO3. Now these two vectors which we have obtained, WO2 and WO3, represent that if our ship moves on course WO2, if our ship moves on a course of WO2 without any change in the speed of the ship, then the new triangle would be WO2A. This is going to result in a line of approach O2A, and effective at 9:45, this will result in the vessel moving on line of approach PN1, coming at CPA at point N1, which is desired CPA of 1.5 miles. Now, if you look closely, the vessel was initially moving on a course of WO. To move on a course of WO2, vessel will have to make a alteration to starboard. So if we make a alteration to starboard equal to angle OWO2, then after this alteration of course, we will be able to achieve a CPA of 1.5 nautical miles. So we now read off the course WO2, and this gives us our new course to steer. Now this is the second option. Now the third option which is available to us is to alter our course to WO through. If we alter our course to WO through, the new triangle would be WO3A. The relative line of approach would be O3A. Again, effective from 9:45, it will make the ship move on a track of P2N1, and this will achieve the desired CPA of 1.5 miles. Now, if the vessel alters its course to WO3, you can see clearly our ship was initially steering WO. We will have to make a port alteration. So alteration of course to port will result in our course as WO3. The amount of alteration is angle OWO3. We can now place our parallel ruler along with line WO3, use the graduations on the circumference and measure our new course, WO3 course. So when we measure these courses, course WO2 comes as 081 degrees true. This is the first course alteration option to us. And WO3 comes to be 332 degrees true. This is the second course alteration which is available to us. So in all these three options, if we reduce speed to WO1, option number 1, if we alter our course to starboard and start moving on WO2, this is option number 2. And if we alter our course to port and start moving on a course of WO3, in all these three cases, the line of approach is in the direction of B2A. Effective from 9:45, any one of these actions will result, or you can say all three of these actions will result in the ship moving on Papa November 1 new line of approach, maintaining the required CPA, closest point of approach. So we have three options available to us now. First option is reduced speed to 10 knots, resulting in on ship vector as WO1. Second option is alter course to starboard to the new course of 081, which is WO2. Third option is alter course to port to a new course of 332 degrees, which is the course of WO3. So with all these three options available to us, we now evaluate the plot and we are able to observe that these two ships, own ship and the target ship, are crossing with a risk of collision. Own ship is also having the target on her starboard side. Now, as per ROR, the crossing situation rule, own ship has to keep out of the way and shall, if the circumstances of the case admit, avoid crossing ahead of the other vessel. So as far as ROR is concerned, none of the three actions contravene or contradict with ROR. All three of them are acceptable as per ROR. However, alteration of course to port is ruled out in this particular case, because if we alter to port, one, it requires a much larger alteration. The amount of alteration which is required is much larger compared to the starboard alteration, and even if you do it, the own ship would have to remain off course for a very long period of time. You see, the rate of approach will become very less. O3A gives you the rate of approach, and our ship will have to stay off course for a much longer period. So alteration to port is not recommended in this case. Now, out of the remaining two possibilities, that is alteration to starboard and reduction of speed, whenever the ship is out in open sea and we have good visibility, in this case there is no mention of any restricted visibility, so we assume there's good visibility. Alteration of course is always preferable to a reduction of speed. One, it is easier to do, and second, it would be readily apparent to the other vessel. So out of the three options which are available to us, the most appropriate option would be to alter our course to starboard. The new course would be WO2, line of approach would be O2A. Effective at 9:45, it will make the ship move on the new line of approach, Papa November 1, having its CPA at November 1, which is the required CPA of 1.5 miles. The new course to be steered is 081, effective from 0945 hours. Go ahead with your doubts, beta, if any.
So, can you please show the previous slide, sir?
Previous slide, beta?
Yes, sir. Previous slide.
Okay, all right. I'll show you, beta. Any doubts in this particular slide, in this question?
No, sir. I just need to take a photo of it.
Okay. All right. Great. Let me show you the previous slide. Here it is, beta.
Okay, sir.
Done, beta? Okay, great. Very good, beta. So this was the method of how to predict what action is to be taken, how to find how many possibilities are there with which we can attain the required CPA, and out of these three, which is the most appropriate. Great. So can I close this now, beta? Shall we move on to the next one? Okay, beta. Great. So I'm closing this down. Let's move on to the next topic. Okay, all right. Now we have seen the basics now. Now we come to more tricky questions, more complicated questions, where there can be multiple targets. In the last question, we saw there was a single target and we had to take action to keep out of that target. But what is to be done if we have multiple targets? So let us see what approach do we follow, what is the concept, and how do we take care of multiple targets. Let's go. Now, having understood a basic plot and having seen the method to predict the action to be taken by ownership, we are now ready to go into the questions involving multiple targets, more than one targets. So this very nearly corresponds to the practical situations which we face on board. We may have multiple targets close to us and we may be required to take action following the ROR. Now, when we are having multiple targets, more than one targets, the main question or main doubt which arises is that our action should be basis which of the three targets, which of the two targets or three targets. So for that, in case of a close quarter situation developing with multiple targets, we follow the priority like this. In case of targets with different TCPA, that is the time for closest point of approach, the earlier occurrence poses a greater risk than the later one. So we check the TCPA of all the targets. The target having the minimum TCPA, which means earliest occurrence, that target poses the greater risk than the one whose TCPA is occurring at a later time. Now, in case we have multiple targets with similar TCPA, both the targets or all three of the targets are having a similar TCPA, the one with a closer CPA poses a greater risk to us. Now, once you find out or pinpoint the target which poses a greater risk, the target that poses a greater risk would require an action of greater magnitude. Hence, during evaluation, choose the action suitable for the greater risk target and then check this action suitability for other targets also. This will ensure that the vessel maintains its required CPA with all the targets which are there close to us. So with this, now let us proceed to few questions having multiple targets and see how do we solve them. So is this clear, beta? Any doubt in this? How to identify a greater risk target? Very good, beta. Great. Let's move ahead. Let's see practical examples. So we have our next question on the screen now. The question says, own ship's course is 240 degrees true and speed of 15 knots. In restricted visibility, observes the following two targets, target C and D, target Charlie and target Delta. First observation is made at 1000 hours. The bearing of target C, target Charlie is 314 degrees true and the range is 11.9 miles. For target Delta, the bearing is 208.5 degrees true and the range is 10.0 miles. The next observation is taken after 12 minutes at 10:12. The bearing of target C Charlie remains 314 and the range is 8.3 miles. The bearing of target D Delta is 211 degrees true and the range is 5.1 nautical miles. We have to find the CPA range, CPA time, course, speed, and aspect of these targets at 10:12. Master decides to take action at 10:16 to have a minimum CPA of 2 nautical miles. Evaluate the possible alternatives available to the master and explain which of them is most preferable. Now, some important points from the question. First thing which we notice is that the ship is in a restricted visibility area. So we have rule number 19 in force. The second thing which we notice is target Charlie has its bearing as 314 at both the observations, and the range is reducing. So the target Charlie is on a collision course. So the first part of question is exactly what we have done till now. So let us first plot these two targets and find out the CPA range, time, course, speed, and aspect of both of them. Let us first have the plotting sheet. We have the plotting sheet on the screen now. Let's mark the center of the plotting sheet as C, Charlie. Let's mention the scale which we will be using. The scale is 1 centimeter equal to 1 nautical mile. Let's now mark the course and speed of own ship. Own ship is steering 240. So you see the green color arrow coming up on the circumference of the plotting sheet at 240. Speed is 15 knots, so speed is also marked. Let us first plot the target C, target Charlie. The range is 11.9 miles and the bearing is 314. So on a bearing of 314, at a range of 11.9 miles as per our scale, we plot our first position, and this position is applicable for 1000 hours. We mark the time along with the position, and this is named as O, Oscar. Let's plot the second position. We have the second position here. The bearing remains the same, 314, and the range is now 8.3 miles. This observation is taken at 1012 hours, and as per our system, the point is named as A, alpha. Now let's join the line OA and extend it. Oscar alpha line is joined and extended, and this gives us the relative line of approach of target Charlie. We can see the relative line of approach is passing exactly from the center or from the own ship position, indicating that the target is on a collision course. Let us now plot own ship's course vector. So from point O, in the reverse direction of our course, we mark off this green color vector, O to W. Now WO represents own ship's course and distance steamed in the plotting interval of 12 minutes. Now if we join W with A, whiskey with alpha, WA vector gives us the course and the distance covered by the target within the plotting interval. So we have the WA vector representing the course and the distance covered by the target in the plotting interval from 1000 hours to 1012 hours. So the information what we obtain from plotting is target Charlie is on a collision course. We can also find out the time. The time can be found by measuring distance alpha to Charlie divided by Oscar to alpha multiplied by 12. So Oscar to alpha distance is covered by the target in 12 minutes. We find out how much time would the target take to come to Charlie, and that would give us the time to CPA. So we obtain from the plot target Charlie is on a collision course and the collision is predicted at 1040. The course of the target Charlie is 180 degrees true and the speed is 20 knots. WA distance has been covered by the target in 12 minutes. So interpolating for 1 hour, we get the speed as 20 knots. We also obtain the aspect. The aspect in this case is 46 degrees red. That means we are 46 degrees onto the port side of the target Charlie. Let us now plot our second target delta. For target delta, the first bearing is 208.5, range is 10 miles. So on a bearing of 208.5, at a range of 10 nautical miles, we plot the first relative position of target delta. This is applicable at 1000 hours and we name that position as O, Oscar. The second bearing is 211 degrees true. So at a bearing of 211, the range is 5.1 nautical miles. As per our scale, at a range of 5.1 nautical miles, we plot the second position of the target delta. This is taken, observation is taken at 1012 hours, and this position is named as alpha. Now we join Oscar to alpha and extend this line. Oscar to alpha line extended gives us the relative line of approach. Now from point Oscar, we mark our own ship course and distance in the reciprocal direction, in the reverse direction. You can see the green color vector coming up. The free end of the vector is named as W, whiskey. Whiskey to Oscar represents own ship's course and distance covered in the plotting interval of 12 minutes. Now if we join W to A, whiskey to alpha, this vector whiskey to alpha gives us the course and distance of target delta. So we can measure off the course and distance of the target delta from WA vector. So when we measure this information, obtain this information, we come to know that the CPA for target delta is 0.4 nautical miles. You can see this is the CPA here. You have to drop a perpendicular from Charlie to the relative line of approach that will give you the CPA. The CPA is 0.4 miles and it is happening at 10:24. Again, we can measure the distance between alpha to the CPA point. Now the ship has covered a distance of Oscar to alpha in a interval of 12 minutes. Interpolating for this distance, we can find out what is the time at which the CPA would occur. And in this case, the CPA time comes to 1024 hours. We can measure the course of the target by the direction of WA, and the course comes out to be 351 degrees true. We also know the target has covered a distance of whiskey to alpha in 12 minutes. So interpolating it for 1 hour, we get the speed of the target, which is 15 knots. We also find out the aspect of own ship. So the angle between the heading of the target vessel and the bearing of our own ship from the target, that comes to 40 degrees and it is green because our ship falls on starboard side of the target. So first part of the question is done. We have plotted both the targets. We know their CPAs, DCPAs, the course and speed of the target is known and the aspect is also known. Now we can see here from the information what we have obtained. This question is set up in restricted visibility. So vessels are not in sight of one another. Now as per rule 19, any of the three ships is free to take any action to avoid a close quarter situation. However, we can observe here that each ship has the other two ships forward of her beam. You can consider any particular ship. You can consider target Charlie. Both the other ship, own ship as well as target Delta, are forward of her beam. You can consider target Delta. Both our ship, own ship, as well as target Charlie is forward of his beam. And you can consider own ship at Charlie. Both the ships, target Charlie as well as target Delta, are forward of our beam. Hence, as per Rule 19, none of the three ships is permitted to alter course to port. So, in view of this, own ship is having only two options which are available to the master. One is a alteration of course to starboard, and the second is a reduction of speed. So we will now evaluate both these actions, and we will see which of them is most preferable and recommended in this situation. Now, how should we evaluate the action? Which target shall we take to evaluate the action? Should it be target Charlie or should it be target Delta? Now, if you have a look at CPA of both the targets, that is indicating either a collision with target Charlie, and with target Delta, the CPA is very less, that is 0.4 miles. So there is no major difference in the CPA. But if you have a look at their TCPA, the time to closest point of approach, the TCPA for target Charlie is happening at 1040, whereas for target Delta it is happening at 1024. That is about 16 minutes before target Charlie. So since the CPA with Delta is happening 16 minutes earlier, we will take a action to have a CPA of 2 nautical miles or more for target Delta, because target Delta has the priority over target Charlie because of the frequent or earlier TCPA. So we will first evaluate our action basis target Delta, and then we will check this action for target Charlie. Now, since we need a CPA of 2 nautical miles, let us first plot this CPA circle, keeping our compass at the center of the plotting sheet at point C, point Charlie. I open up my compass equal to 2 nautical miles and draw my CPA circle. So we have our CPA circle. Now the question says that the action is to be taken at 1016 hours. So let us first predict the position of target Delta at 1016 hours. We know target Delta has moved from Oscar to Alpha in 12 minutes. So interpolating it for 4 minutes, we can obtain the location of target Delta, predicted position of target Delta at 1016. So you can see the predicted position P Papa coming up on the plot. Now from Papa, I draw a tangent to my CPA circle. You can see this tangent coming up. Now there are two possibilities for drawing the tangent. You can see the first possibility, Papa to November 1. The second possibility is on the other side of the CPA circle. You can see the second possibility now, Papa to November 2. So if our line of approach from point P, from point Papa, changes over to Papa November 1, we will have a 2 mile CPA. Or the other option is that if our line of approach changes over to Papa November 2, we will again have a 2 miles CPA. So there are two options which are available to us. CPA can occur at November 1 or November 2. So let us evaluate these two options one by one. So what we do first is we pick up the line of approach Papa November 1. We align our parallel ruler to this particular line, take our parallel ruler to point alpha and draw a line parallel to our new relative line of approach, that is Papa November 1. So you can see this line coming up on the plot. Now what I do is I open up my compass equal to WO, Whiskey Oscar, for target delta. Center my compass at point W, Whiskey point, and draw an arc. You can see this red color arc coming up on the plot. The arc is centered at Whiskey and the radius is equal to Whiskey Oscar. Now this arc intersects our new relative line of approach at this particular point. So let us name this particular point as Oscar 1. Now we join W to Oscar 1. You can see the W to Oscar 1 vector coming up. Now this W to Oscar 1 gives us our first option. If the ownership course becomes W Oscar 1, then the triangle which we will have will be W Oscar 1A. The relative line of approach will become O1A, and effective at 1016 hours, that is at point Papa, this relative line of approach will take the target on Papa November 1 track, and when it reaches at November 1, it will have a CPA of minimum 2 nautical mile. Now we align our parallel ruler or set square or sliding ruler to W Oscar 1 and measure this course using the plotting sheet as a compass rose. We measure the course and this comes to a course of 317 degrees true. 317 degrees true. So if ownership alters course to 317 degrees true, initial course is 240, so that's an alteration of 77 degrees to starboard. If our ship alters course to 317 degrees true, effective at 1016, the target will have a CPA of 2 nautical mile at point November 1. Beta, any doubts coming up to here?
सर ये एस्पेक्ट का एक बार बता देते क्या क्वेश्चन होने के बाद चलेगा.
Okay. All right, let's do this, then I'll explain to you. Okay, let's proceed ahead. अभी एक option आया है बेटा हमारे पास. Let us explore other options. Now let us evaluate the effectiveness of this action for target Charlie also. So what I do is at point Whiskey, now I draw my new course. My new course would be 317 degrees true. So you can see this green color vector coming up. And let us name this as O1, this point, the free end of the vector. Now if I join O1 with A, this is going to give me the new relative line of approach for target Charlie. So the length of WO1 is exactly same as WO. There is no change in our speed. So this is indicated by this arc also here. Now we join Oscar 1 to Alpha. This will be our new relative line of approach. Since this is effective at 10:16, so let us first predict the position of target Charlie at 1016 hours after 4 minutes. So interpolating this difference, the distance Oscar to Alpha. Oscar to Alpha is covered by target Charlie in 12 minutes. Interpolating, we obtain the predicted position of target Charlie at point P here. Now we transfer the new line of approach, that is Oscar 1 Alpha to point P. So you can see a line parallel to Oscar 1 Alpha coming at point P. This will be the new relative line of approach for target Charlie. you can see 3 arrows coming up. 3 arrows can be shown to predict the new relative line of approach after a action is taken. Now our CPA will be occurring at this particular point, November 1 here. You can drop a perpendicular from Charlie to this new relative line of approach for target C, and this meets here at November 1 point. And it tells us that the CPA for target Charlie will be more than our required value of 2 nautical miles. So this indicates that this action of alteration of course to 317 degrees true will make the CPA of both the targets more than our required CPA of 2 nautical miles. So this is the first option which is available to us.
सर ये W01 जो arc बनाया for Charlie target, it's the same arc that we have taken for the D also, right?
Exactly, beta. Delta से जो W01 हमें मिला, which we found out, now we were testing that W01 for target Charlie. So
Okay,
this
sir.
W01 vector for delta is exactly same as W01 vector for Charlie.
Okay, understood, sir.
Okay, beta. Great. Let's move ahead. The first option is tested. Now let's see the second option. The second line of approach which we had, the second option was Papa November 2. Papa November 2. So we can now draw this second line of approach, Papa November 2, from point alpha. So I align my parallel ruler to Papa November 2, take it to point alpha, and draw a parallel line. So you can see this parallel line coming up here. This is for target delta. So this can be the second option for our relative line of approach. Now this new relative line of approach from point alpha intersects our WO vector. WO vector, it intersects at this particular point, and let us name this point as O2. So now you see, if our speed is reduced so that in 12 minutes we do not cover a distance of WO, but instead we cover a distance of WO2. You can see this WO2 vector. If we cover a distance of WO2 by reducing our speed in 12 minutes, our triangle would be WO2 alpha. And in this case, O2 alpha would become our relative line of approach. Transferring this approach to point P, that is 1016 hours, we will have the line of approach like this. The line of approach will take the target ship delta at its CPA at point N2. So again, target delta will have its CPA at point N2, November 2. Now we measure this distance, WO2. This distance has to be covered in 12 minutes. We interpolate for this for a period of 1 hour, and that gives us our new speed. And the new speed of our ship comes to 2 knots. So if we reduce the own ship speed to 2 knots, WO2 will be the own ship vector. O2A will be the relative line of approach. Effective at 1016, that is at point Papa. This will take the target to Papa November 2 line of approach. CPA would occur at November 2, and it will be 2 nautical miles. So this is the second option which is available to us. Let us now check the effectiveness of the second option, that is reduction in speed for target Charlie. So let's do that. Our initial own ship vector was Whiskey to Oscar, WO. Now we modify the length of this vector as per our new speed of 2 knots. And this is modified now to WO2 here. You can follow the laser pointer, W2O2. This is the new own ship vector. Now from O2, I join a line with point alpha, you can see Oscar 2 to alpha dotted line coming up. This will be the new relative line of approach for target Charlie. This is effective at 1016 hours. So transferring this line O2 alpha at point P, which is the predicted position at 1016, we have our new line of approach. So you can see this dotted line from point Papa of target Charlie showing up on the screen, and we can clearly see that the CPA of target Charlie has increased from its initial value. So it is much more than 2 nautical mile, which is the required CPA. So we have now seen that this is the second option which is available to us. Reduction of speed. If we reduce the speed to 2 knots, both the ships will have a minimum CPA of 2 nautical miles. Now let's evaluate a third option which can be picked up from this diagram. The third option which is available to us is an alteration of course to port. So you see here, this was our initial course vector for target delta. You can follow the laser pointer. For target delta, our ship course and distance vector was W Oscar. Now, if instead of W Oscar, if we steer a course of W to this particular point here, O3, you see this is the arc which we had drawn representing our distance in 12 nautical miles. And this was the line of approach, Papa November 2 line of approach drawn at point A. They were intersecting at this particular point. We name it as O3. So if own ship alters course to WO3, then WO3A would become our new triangle. O3A would be the new relative line of approach. Effective at 1016, that means at point Papa, this relative line of approach would take the target on Papa November 2 track, and it will have a CPA of 2 nautical miles. This option is also available as per radar plotting, but this option is prohibited by ROR Rule 19. Any alteration of course to port is prohibited. So we cannot take this option. WO3 option is not allowed. So we have two options now available to us. One is alteration of course to starboard by 77 degrees. Second is reduction of speed to 2 knots. Now among these two alternatives, reduction of speed is certainly preferable and recommended in this case, because in restricted visibility, it is always more prudent to reduce the speed than to alter the course of the ship drastically. We need to have an alteration of 77 degrees to starboard. Now, this kind of a bold or drastic alteration will not only take longer to execute, it will take much more time to execute, but may also result in a close quarter situation with some other ship. So reduction of speed, on the other hand, will be effective, will be much quicker, and is also recommended. In restricted visibility, reduction of speed is always preferable and will keep the ship safe. So out of these options, the recommended option is reduction of speed to 2 knots and making the required CPA, having the required CPA with both the targets.
So,
Go ahead, beta.
that is 2 knots is below the minimum steerage speed. Then also, is that okay?
You see, beta, one, they have not mentioned anything about the minimum steerage way. And second, in all these questions, a gold standard to check which action will be appropriate is that in restricted visibility, 99% of the time, reduction of speed will be more appropriate. Because in restricted visibility, we always avoid huge alterations of course. Because there may be a ship which may be following us or overtaking us. A huge alteration is going to put that ship in a tricky situation. So that's why always, as per ROR, in restricted visibility, give preference to reduction of speed as compared to the alteration of course. Forget about steerage way. Even if you need to stop the ship or even if you need to go astern, that is also to be done.
ठीक है sir. Okay. Sir, second question is this.
Right.
Now over here we have two line of approaches. This PN1 and PN2.
Right.
So in both the questions which we have done so far, there is a line of approach which is, for example, a PN1. When we drew parallel to it, there is no chance that we can achieve this line of approach by reduction of speed, right?
Yes, that's right, beta. That's right. You can
sir,
see
so
that whatever
how many
increase.
so how many ever situations come, sir, we will always get it like this, that one line of approach will result in alteration and speed, and the other line of approach will be only alteration.
No, it will not happen this way in all the questions. It may change slightly question to question. Basically, you have to check कि जो आपकी नई line of approach है, by reducing your own ship vector, WO को आप increase या decrease करने पे अपनी new line of approach तक पहुंच रहे हो या नहीं. So you will have to visualize and see that. जैसे इस केस में we can see कि irrespective of how much increase or decrease we do to WO vector, WO is almost running parallel to the new line of approach. So any reduction or decrease or speed or increase of speed is not going to take us to the new line of approach. So it may differ from question to question, beta. Every question we'll have to give a good look to the plot.
Okay, so basically we might have to plot four things, like alteration to starboard, increasing speed, alteration to port, reduction speed.
Yes, that's right. That's right. There could be these options, but in May, increase of speed will be immediately ruled out because you see increase in speed, you cannot cross your safe speed at any time. Especially in restricted visibility, increase of speed will be totally ruled out. So you can give that option, say that there is a possibility if it is there in his question, and then you can write a remark that this is not recommended in restricted visibility.
Okay, sir, because the more options we take, the clutter our plotting is going to be. So, for example, यहाँ पे port पे O3 दिखाया, but O3 we did not show. We just ruled it out. Same way, we will try to rule out as much as possible.
Yes, that's right, beta. That's right. They can become quite congested. Okay, पर जो ये question मैंने आपको दिखाया है, this is one of the most congested ones. So इतना ही plotting आएगा, इससे ज़्यादा बनेगा नहीं.
ठीक है सर, ओके.
ओके, अब मैं बेटा आपको इसका एक और भी एस्पेक्ट दिखाता हूँ. लेट मी मेक इट ऑल द मोर क्लियर. अब हमने यहाँ पे देखो अपनी प्लॉटिंग से तो टेस्ट कर लिया कि भाई दो ऑप्शन थे हमारे पास. वन वाज ऑल्ट्रेशन टू स्टारबोर्ड, अनदर वाज रिडक्शन इन स्पीड. सो वी हैव प्रेफर्ड रिडक्शन इन स्पीड. नाउ अगर आप इसमें शिप्स की एक रफ डायग्राम भी डाल दो तो immediately the scenario becomes very clear. Let me put a rough diagram. मैं तीनों ships की ना यहाँ पे एक diagram डालता हूँ. So in the heading, as you see that diagram, the situation will become totally clear. Give me a minute, बेटा, अभी डाल रहा हूँ. So can you see own ship coming in the screen?
Yes, sir. Yes,
very
available.
Good. Very good. So now you see this is how our ship is moving. Let's put target Charlie. You can now see target Charlie also approaching, and let's put Delta also. So you see this is the scenario, beta. So immediately when you look at the scenario, it becomes clear, crystal clear to you that the reduction of speed in this situation will be the most appropriate action to take.
Yes, sir.
Okay, you don't need to make these rough diagrams in your plotting. This is just shown for your understanding. In the plot, these are not required.
Sir, reduction of speed in 4 minutes from 15 knots to 2 knots. How practical is that also?
Okay, now beta, when you are in restricted visibility, the engine should be on standby. So you should be ready to take action. Not only reduction in speed, you should be ready to go astern also at a moment's notice. So that has to be there.
Okay, sir.
Okay, all right. Clear, beta? Clear?
Sir, I have a doubt, sir.
Bolo, beta.
Sir, regarding this line of approach, like sir, PN1, if we say, then this PN1, sir, cannot be achieved by speed, or we can say that, sir, if this line of approach is not cutting on WO, then this approach cannot be achieved by the reduction of speed or increase of speed, sir.
Yes, that's right, beta. That's right.
Yes.
So regardless of how much you increase your speed, WO vector को अगर आप extend भी कर देते हो, it is not going to intersect with the new line of approach. So this tells us any amount of increase of speed or any amount of decrease of speed will not take you to the Papa November 1 line of approach.
Yes, sir. Yes, sir. And sir, while transferring this line to the target Charlie, sir.
Right.
The PN1, yes, sir. PN1 to when we are plotting, sir, WO1 on Charlie, sir.
Okay. हमने WO1 to Charlie. Okay. All right. WO1 is plotted in Charlie.
The red color arc will be by the shift speed only, right, sir? WO will be the radius of this circle.
Yes, that's right. The radius remains same because हमने सिर्फ alteration की है.
Yes.
So the radius remains same. You can see this red color dotted line also at Charlie, indicating that the magnitude of WO1 is exactly same as the magnitude of WO.
Okay, sir. Okay, sir. Understood, sir.
Okay. Great, beta. So clear है?
हाँ सर क्लियर है सर.
Very good, beta. Great.
तो वो
Understood.
aspect थोड़ा बता दीजिए.
Okay, beta. Okay. Now aspect is very clear, beta. Have a look at delta, target delta. Aspect is basically the angle between the heading of delta, heading of target delta, and the bearing of own ship from delta. So you join both these ships and you draw a line extending the heading of target delta. Angle between them is the aspect. And for delta, the aspect is 40 degrees green because our ship 2 is to the starboard side of target delta. So this angle comes to 40 degrees. Are you able to visualize that better?
Yes, a visualize हो रहा है because I was trying to find a method which does not require me doing on the plot because वो और clutter हो जाएगा.
Okay, all right. Don't make it on the plot बेटा. Don't make it on the plot. देखो आपने टारगेट का जो कोर्स है वो तो निकाल लिया है.
हाँ सर, WA निकाल लिया.
Yeah, it is 351, right?
Correct sir.
And आपके पास टारगेट डेल्टा की 10-12 की बियरिंग भी है. 10-12 बियरिंग is 314.
हाँ सर, 314.
Okay. Now we do not require 314. What we require, target delta की जो bearing, yeah, it is 211. Sorry, 211. Okay. Now we don't require the bearing of delta. We require the bearing of own ship from delta. So you take a reciprocal of 211.
Yes, that is the method, sir.
Okay. 211 minus 180 gives you 031. So
Okay,
031 is your bearing and 351 is the target's course. Angle between them is the aspect beta. Okay. Now if this angle comes more than 180 degrees, 80 degrees, aspect cannot be more than 180. So if it comes more than 180, you subtract it from 360 and the lesser value which you get is the aspect.
Okay, sir.
Okay. Okay, beta. Great.
लेकिन लास्ट क्वेश्चन में एस्पेक्ट आई थिंक 37.5 आ रहा है, वो मैच नहीं कर रहा, 37 ही आ रहा था उसका एस्पेक्ट लास्ट क्वेश्चन में जिससे पहले आपने किया था।
ओके, ऑल राइट बेटा, देयर कैन बी डिफरेंसेस। यू सी, जब आप मैयर करोगे ये जो वेक्टर्स हैं ना बहुत छोटे हैं, WO, WO1, WO2, these vectors are very small. So जब आप स्लाइडिंग रोलर को इस वेक्टर के साथ अलाइन करके सेंटर में लेके जाते हो, देयर कैन बी इजीली ए डिफरेंस ऑफ 2, 3, 4 डिग्रीज तक की भी डिफरेंस आ सकता है. सो दीज आर प्लॉटिंग एरर्स, डोंट वरी अबाउट देम, शुड बी फाइन, नो इश्यूज.
ओके सर, ओके, थैंक यू सर.
Okay beta, great. So shall I close this out now?
Yes sir.
वेरी गुड बेटा, ग्रेट. ओके, अब मुझे ये बताओ बेटा, ये सारी जो रडार प्लॉटिंग है ये आपने आरओसी में की थी, सो ये सब याद आ गया कैसे किया था आरओसी में?
हाँ सर, याद आ गया.
हाँ सर.
ओके, ग्रेट. सो अगर ये आपको याद आ गया, हाउ डिड यू फाइंड द प्रेजेंटेशन? वर यू एबल टू कैच इट अप इजीली?
यस सर, इजीली.
हाँ सर, इजी था.
वेरी गुड बेटा, ग्रेट. सो वंस यू हैव दिस मच ऑफ इंफॉर्मेशन, ये क्वेश्चन अगर आपने प्रैक्टिस कर लिया, it will prepare you for your examination radar plotting questions. So अब मैं क्या करूँगा बेटा, मैं ये जो क्वेश्चन है इसका भी स्क्रीनशॉट शेयर कर दूंगा. दिस इज देयर इन द बुक ऑल्सो. आई विल ऑल्सो शेयर ए स्क्रीनशॉट. एंड एक और क्वेश्चन जो है वो उसका भी स्क्रीनशॉट मैं आपके साथ शेयर कर दूंगा. सो यू कैन प्रैक्टिस दीज 2 क्वेश्चंस फर्स्ट. इनके आंसर्स भी भेज दूंगा आपको, सो यू कैन मैच योर आंसर्स, मैच योर वर्किंग. एंड इन दोनों को करने के बाद बेटा आप पास पेपर्स में जाके जो रडार प्लॉटिंग के क्वेश्चंस हैं उनको अब अटेम्प्ट करना शुरू कर सकते हो. सो स्टार्ट अटेम्प्टिंग देम वन बाय वन. द रडार प्लॉटिंग कॉन्सेप्ट इज डन. एंड किसी क्वेश्चन में आपको डाउट आता है और यू आर नॉट एबल टू मेक ए वे थ्रू, पोस्ट दैट क्वेश्चन ऑन द ग्रुप. ओके, मेरे पास कुछ एक पास पेपर्स के क्वेश्चंस हैं, दे हैव बीन सॉल्व्ड बाय कैंडिडेट्स. सो इफ यू वांट आई कैन शेयर दैट विद यू.
यस सर.
यस सर, शेयर कर दीजिए सर.
ओके, ऑल राइट, वो मैं आपके साथ शेयर कर दूंगा. बट बेटा उनकी वर्किंग आंसर्स में डिफरेंस आ सकते हैं. सो यू वर्क दैट आउट एंड चेक देम, डबल चेक देम. अगर कहीं पे डाउट आए तो यू कैन इंटरेक्ट ऑन द ग्रुप विद ईच अदर एंड यू कैन कंफर्म विच इज द करेक्ट आंसर. ओके, सो आंसर्स की जो करेक्टनेस है वो मैंने वेरीफाई नहीं की है. जस्ट टेक द सोल्यूशन एज ए हिंट.
ओके सर.
ठीक है सर. सर ये जैसे अभी इसमें हमने 2 टारगेट थे, 2 टारगेट में से एक हमने चूज किया, मतलब गोइंग बाय द प्रायोरिटी स्टेप्स. सर ऐसा तो नहीं आने वाला ना कि 2 टारगेट आ जाता है दोनों की सेम प्रायोरिटी होगी? ऐसा तो बिल्कुल नहीं होने वाला ना सर?
नहीं बेटा, ऐसा नहीं होगा कि दोनों ही मैच कर जाएंगे. देखो मैंने आपको बताया कि सबसे पहले तो TCPA देखना है. जो टारगेट अर्लियर अकरेंस वाला है उसे हम अपना प्रायोरिटी टारगेट मानेंगे and we will take action as per that and test it on the other one. And अगर किसी केस में आपका TCPA सेम आ रहा है और close to each other, I would say if the difference is less than 5 minutes, 5 मिनट के अंदर अंदर दोनों टारगेट अपने CPA पे आ रहे हैं, then you have a look at the CPA range. जिसका CPA रेंज कम है उसको अपना प्रायोरिटी टारगेट बनाओ and take action basis that target. So this in 99% of the cases will make you clear from the other target also. जो एक्शन आप एक टारगेट से लोगे वो दूसरे के साथ भी आपकी कंडीशन सेटिस्फाई कर देगा. ओके,
ठीक है सर, बढ़िया सर.
ओके, अब एक और बात सुनो बेटा. अब तुम जब यहाँ तक पहुँच गए हो, देयर कैन बी ए 1% चांस. ऐसा चांस एक 1% हो सकता है कि आपने प्रायोरिटी टारगेट लिया, उसके बेसिस पे एक्शन लिया एंड ये एक्शन जो है दूसरे टारगेट को सेटिस्फाई ना करे. आपने प्रायोरिटी टारगेट का CPA अकॉर्डिंगली अपनी ऑल्ट्रेशन निकाली. यू टेस्ट दिस ऑल्ट्रेशन टू अदर टारगेट एंड अदर टारगेट मे बी हैविंग लेसर CPA, 1% चांसेस देयर. अगर ऐसा हो जाए, दैट इज ए बाउंसर क्वेश्चन. अगर ऐसा हो जाए तो फिर आपको बेटा रीवर्क करना पड़ेगा. You will have to go to the other target, take your action basis that, and then you don't need to check it for the first target, क्योंकि जब आप दूसरे टारगेट से एक्शन लोगे तो ऑब्वियसली पहला वाला फिर सेटिस्फाई हो ही जाएगा. सो देयर इज ए 1% पॉसिबिलिटी ऑफ दैट काइंड ऑफ क्वेश्चन कमिंग इन. ओके,
सर इससे पहले कभी ऐसा क्वेश्चन आया क्या सर?
बेटा मुझे जहाँ तक मुझे याद आता है ऐसा शायद एक क्वेश्चन आया था, दैट लॉन्ग लॉन्ग टाइम बैक, मे बी 4-5 years बैक, एक क्वेश्चन ऐसा आया था जिसमें ये हुआ था। ओके
ओके सर, ओके सर।
ओके ऑल राइट बेटा।
सर इसमें वो बात नहीं समझ आई कि पहले वाले के लिए ठीक है हम एक्शन ले रहे हैं, दूसरे वाले के लिए आप बोल रहे हो कि it will not satisfy, so you decide for the second target. When you go for deciding, we will again have one alteration to starboard, one alteration to port, and one reducing. Then any action taken for the second, how will it satisfy all the criteria for first?
ओके देखो बेटा, आपने एक प्रायोरिटी टारगेट पिक किया, यू टुक एक्शन एज पर दैट। जो दूसरा टारगेट है वो आपके क्राइटेरिया को सेटिस्फाई नहीं कर रहा, उसका सीपीए अभी भी रिक्वायर्ड सीपीए से कम आ रहा है। ओके
ठीक है सर।
हाँ, इसका सिंपली मतलब यही है कि जो दूसरा वाला टारगेट है उसके लिए आपको ज़्यादा बोल्ड ऑल्ट्रेशन चाहिए या मोर रिडक्शन ऑफ स्पीड चाहिए। सो आपने जो रिडक्शन की थी दैट वाज नॉट अप्रोप्रिएट, यू विल हैव टू रिड्यूस इवन मोर। या जो ऑल्ट्रेशन आपने की थी दैट वाज नॉट अप्रोप्रिएट, यू विल हैव टू ऑल्टर इवन मोर। जब आप ज़्यादा ऑल्ट्रेशन करोगे या ज़्यादा रिडक्शन इन स्पीड करोगे तो पहला वाला टारगेट तो ऑलरेडी बाहर जा चुका था, वो तो और ज़्यादा क्लियर हो जाएगा।
ठीक है सर।
ओके ओके बेटा ग्रेट।
सर एक जस्ट फाइनल एक पूछना था, तो ये प्रायोरिटी टारगेट चूज करने के लिए we'll just first take consideration CPA, और अगर CPA इक्वल है then CPA
फर्स्ट इज TCPA बेटा।
ओके ठीक है सर।
फर्स्ट इज TCPA, अर्लियर अकरेंस यू गिव द फर्स्ट प्रायोरिटी।
ओके एंड सर इफ रिस्क ऑफ कोलिजन इज एग्जिस्टिंग देन ओनली वो प्रायोरिटी होएगा।
नो अगर TCPA या आपने देखा कि दो टारगेट है, एक का TCPA जो है वो अर्लियर अकरेंस आ रहा है, दूसरे का लेटर अकरेंस है, बट द अर्लियर अकरेंस इज नॉट हैविंग एनी रिस्क ऑफ कोलिजन, वो वैसे ही पास हो रहा है। ऐसा होगा नहीं किसी क्वेश्चन में, बिकॉज दैट विल सिंप्लीफाई द क्वेश्चन। जब आप देखोगे तो दोनों टारगेट जो हैं वो CPA को ब्रीच कर रहे होंगे, बिकॉज अगर पहला टारगेट क्लियर हो गया तो आपका तो 50% क्वेश्चन वहीं पे सॉल्व हो गया। सो ऐसा आएगा नहीं, बट अगर आ जाता है, आपने जो प्रायोरिटी टारगेट को पिक किया और आपने देखा वो तो क्लियर ही है, सो नेचुरली देन यू विल हैव टू मूव ऑन टू द सेकंड वन।
ओके सर, ओके
ओके ग्रेट बेटा। सो अब एक ब्रेक ले लेते हैं बेटा, हमारा प्लॉटिंग वाला टॉपिक कंप्लीट हो गया है एंड नाउ वी कैन मूव ऑन टू जो मैग्नेटिज्म का हमने बेसिक चैप्टर शुरू किया था, वी कैन डू दैट। आर यू ओके टू कंटिन्यू विद मैग्नेटिज्म और आर यू फीलिंग ओवरलोडेड? तो नहीं फील कर रहे बेटा? हाई लेवल अलार्म तो नहीं आ रहा?
नहीं सर बढ़िया।
मेरा फर्स्ट क्लास थोड़ा सा है।
कंफर्टेबल है? अलेज इज देयर?
लिटिल बिट।
हाँ सर थोड़ा अलेज बचा है।
थोड़ा सा।
ओके बिकॉज बेटा मैं आई डोंट वांट टू डिस्टर्ब, जो आपने आज सीखा है मैं उसे डिस्टर्ब नहीं करना चाहता। सो इफ यू फील लिटिल ओवरबर्डन्ड तो हम लोग रुक भी सकते हैं, वी कैन टेक ए ब्रेक फॉर टुडे एंड वी कैन स्टार्ट द मैग्नेटिज्म टुमारो, दैट इज आल्सो पॉसिबल। इफ यू आर कंफर्टेबल देन वी कैन कंटिन्यू।
ब्रेक ही ले लेते हैं आज के लिए। मेरा सर मे भी अलग होगा क्योंकि मेरा फर्स्ट क्लास है, मे भी सर ऐसा हो सकता है। मेरे को थोड़ा ज्यादा बर्डन लग रहा है।
Okay, so as you say beta, what other people say? Shall we stop today or shall we continue?
Yes sir, stop sir।
Okay, all right, ठीक है बेटा, ठीक है। तो आज के लिए यहाँ रुक जाते हैं।
Continue for magnetism sir।
ओके ओके। अब बेटा अगर 3-4 बच्चे बोल रहे हैं कि यहाँ रुकना है, वी कैन स्टॉप हियर, नो प्रॉब्लम एट ऑल। ओके, बिकॉज आई डोंट वांट दिस टू बी ओवरबर्डन्ड एंड वॉश्ड आउट फ्रॉम द माइंड। सो कंटिन्यू, डोंट वरी, वी हैव एनफ टाइम, वी कैन कवर अप द सिलेबस वेल। ओके, सो लेट्स टेक ए ब्रेक फॉर हियर टुडे एंड कल हम मैग्नेटिज्म को आगे कंटिन्यू कर लेंगे, बिकॉज मैग्नेटिज्म में भी अभी जो फर्स्ट टॉपिक हमने किया था दैट वाज ए बेसिक मैग्नेटिज्म स्लाइड। इसके बाद जो नेक्स्ट टॉपिक आएगा दैट विल बी शिप्स मैग्नेटिज्म। शिप्स मैग्नेटिज्म में थिंग्स विल स्टार्ट टू गेट लिटिल ट्रिकियर। hard iron, soft iron, permanent magnetism, induced magnetism. So don't worry. आज के लिए हम लोग stop करते हैं यहाँ पे. Start to practice these questions. I will share the questions also with you. And tomorrow be ready for magnetism. And कल हम magnetism में ships magnetism cover करेंगे. And maybe after that coefficients will come in. So maybe we will pick up the first coefficient also. Right?
Okay, sir. Okay.
Yes, sir.
Okay.
Thank you, sir.
All right then. We break off for today. And I will see you tomorrow, same time.
Okay, sir. Thank you, sir.
Okay,
Okay,
sir.
beta. Bye-bye.
Bye-bye, sir.
Thank you.